Problem 9, evaluate the integral 5 secant squared x dx. Hopefully you are very familiar with this, knowing that there is an integral. We know that the integral of secant squared x dx is equal to tangent x plus c. So the only thing different in this problem is there's a 5 there. We don't need it, so we can just bump it out front. So I'm going to rewrite it to look like this. And so now this will be 5 tangent x plus c. That's all you have to do. It's just formula recognition. Do you know your formulas? Problem 10, evaluate the integral x cubed plus x all over x to the 5th dx. First thing that we're going to do, since we have no quotient rule on integrals, is we're going to bump the x to the 5th up top. So I'm going to have x to the x cubed plus x, and then times x to the negative 5. The next thing that we're going to do is distribute. So I'm going to add my exponents. I'll get x to the negative 2 plus x to the negative 4, still dx. Okay, then from here, since there's a plus sign, we can just take the integral of each part separately. Remember, we'll just add 1 to the power and multiply the in front by the reciprocal. So if I increase this power by 1, I'll get x to the negative 1. The reciprocal of negative 1 is negative 1. Next part, increase my power by 1, I'll get x to the negative 3. The reciprocal of negative 3 is negative 1/3. So now rewriting this so I don't have negative exponents, I'll have negative 1 over x minus 1 over 3x cubed plus c, and I am done. Okay, find f of x if the second derivative is equal to x to the negative 3 halves, f prime of 4 equals 2, and f of 0 equals 0. Before I start this, let's point out that the 4 is an x, the 2 is a y, the 0 is an x, the 0 is a y. All right, I need to get back to the original function. I'm at the second derivative, so the first thing that I want to do is take the integral, because that will get me to the first derivative. If I use my power rule, if I increase my power by 1, that will be x to the negative 1/2. The reciprocal of negative 1/2 would be negative 2. If I rewrite that, because most people don't like dealing with negative exponents, I'm going to get negative 2 over the square root of x plus c. Okay, I will now use this information right here to help me find the c. I know my derivative is equal to 2, and I know my x value is equal to 4. So I'll get 2 equals negative 2 over 2 plus c. 2 equals negative 1 plus c, c equals 3. So if I rewrite this, f prime of x equals negative 2 over the square root of x plus 3. Okay, now I'm going to rewrite this so that I can actually take the integral here. So this will be negative 2 x to the negative 1/2 plus 3. Okay, to get from the first derivative back to the original, again, I'm going to take the integral of both sides. So I will end up getting f of x. On this one, if I increase my power by 1, I'll get x to the 1/2 times the reciprocal up front, which will be 2. And then plus the integral of 3 is 3x. So if I rewrite this, I will get negative 4 square root x plus 3x, of course, plus c again. And then I will use this information, f of 0 equals 0. So my function equals 0, and my x value equals 0, which means c will equal 0. So my final answer will be f of x equals negative 4 square root x plus 3x, and that would be my answer.